Hello, welcome to the third lecture of the Advanced Programming with Java course at UL University. In the previous two lectures, I gave you an overview of a revision of what you have taken in the programming courses at UL so far. Basically, I reviewed for you the main concepts that you should have already taken in the P1 and P2 courses. In this lecture, we are going to start with the actual content of this course. The first thing that we are going to tackle in the advanced Java course is JavaFX topic. JavaFX is related to how to build graphical user interface applications with Java. In this first lecture, I will introduce Java as X. I will give you an overview of what JavaFX is about. What does it contain? I will explain to you the basic elements in JavaFX, how we can create Java applications with the graphical user interface using this tool, and I will give you a brief example. So towards the end of the lecture, I will give you a brief example, first example about how to apply what we are going to learn related to JavaFX components and elements. To start with, we can say that JavaFX is the last model or framework that was developed by Java for the programmers to create applications that contain a graphical user interface. The nice thing about JavaFX is that it allows the programmer to create application that is in general platform independent, which means that you can create your application on a certain platform, on Windows, Mac, Android maybe, and then you can use the same application on any other platform and the application will still work. This is what we mean in general by platform independent. This is one of the main achievements and the main distinctions in JavaFX as compared to previous graphical user interface models or frameworks that were created by Java, which we'll talk about shortly, which are mainly the AWT and the Swing models. Both of these models, AWT and the Swing, that were created by Java before JavaFX, they didn't support or maybe supported, but to within a certain limit, the concept of platform independence. But with JavaFX, you can expect that any application that you create will be platform independent, which means that you can create a web application and you can use the web application on any web browser within Mac or Android or Windows. You can create a mobile application and you can use the same mobile application with the same code on different platforms. So with JavaFX, you can create three main types of graphical user interface based applications, which are desktop applications, those that will run as standalone software within desktop, within a desktop operating system, such as Windows, Mac, Linux, or any other type of desktop operating system. These operating systems, when you create an application with Java that will run on one of these operating systems, it will be called a desktop application. This is the first type of GUI-based applications that you can create using JavaFX. The second type of applications you can create with JavaFX is web-based applications or internet applications. These applications usually they run within browsers. And as I told you, JavaFX will allow you to create a web application that will be supported by all browsers that exist and all those that support Java in general. The third type of applications you can create with JavaFX. Now remember, when I say here applications, I mean graphical user interface applications that contain graphical user interface. The third type of applications that you can create with JavaFX is mobile applications, which are applications that run on mobile operating systems such as Android, and iOS. In general, you have three editions of Java. You have the standard edition, you have the enterprise edition, and you have the mobile edition. Now, the standard edition usually will run for you desktop applications. The enterprise edition, the EE, will run for you web applications. And if you want to run mobile applications, you need to install on your mobile device the mobile edition of Java, Java Mobile Edition. So what is JavaFX? We can say that JavaFX is a platform, a complete system that runs on top of the Java virtual machine. So if you don't know about the Java virtual machine, you can do some searching on the internet. If you don't know, I advise you to do this searching because it will be very good for you to know the basics of Java before we can continue with the remaining of the course. As I said, JavaFX is a complete system platform that runs on top of Java virtual machine. This platform will allow the user to create applications, to create code packages that will offer certain services and will provide certain content to users. Now, these services might be standalone services within the application. They might be web services. If you are creating a web application, you can connect from your JavaFX application to web services and consume, for example, the services of certain web servers and use the service provided by these web server applications on your device. All of these options, they are offered, they can be created using JavaFX. Within JavaFX platform, you will find many separate packages and tools, such as the designer tools, the developer tools here. These are created within JavaFX to allow programmers and designers to add new components, new elements to Java, and to modify also the existing elements, graphical elements and graphical components in Java. This can be done by utilizing these tools in order to add new code, add new classes, new components, and modify also the current components by altering their functionality in a certain way. In addition to these tools, the JavaFX contains several packages and elements that allow the programmer to use them in their applications to offer various services and various functionalities within a certain application to the user of the application. For example, we have three main types of components, of graphical components: the desktop elements, the mobile elements, and the TV elements. As their names apply, the desktop elements contains the components and graphical elements that are used in desktop applications. The mobile elements, they are used within mobile applications, and the TV elements, they generally are used in multimedia applications. Now, there are some common elements that can be used, common components, graphical components that can be used in all of the three different types of applications that you can create with JavaFX. These are the common elements here. And you have the JavaFX runtime, in which exists within the JavaFX platform in order for it to compile the code that you write in the JavaFX project and produce the binary code of this Java code. So after this general introduction on JavaFX, I will describe briefly, very briefly, the history of JavaFX. How did the graphical user interface in Java start with AWT? Then I will talk about Swing, which was an enhancement, a new model for AWT after 2 years of its development, which was standardized for about 10 years. And finally, after 10 years of Swing, Java put into use the JavaFX platform, which will be the focus of this chapter. So the first graphical user interface platform that was created and put into use by Java was the AWT, which stands for Abstract Windows Toolkit. AWT was fine at that time in 1996, but it contained only primitive and very simple graphical components and elements. If you want to create a comprehensive GUI project in which you want to use complex components, complex graphical elements, you cannot do that with AWT. So simply it is used for very primitive, very simple applications, graphical applications that will contain simple elements. Another thing about AWT, which is a disadvantage, is that it is prone to platform-specific bugs, which means that you create a certain code, you run it on a certain platform, it is okay. When you take the same code and run it on another platform, it will give you an error. So there are bugs that are specific, they occur within specific platforms only. So you might find that your code is okay on a certain platform, it runs well. On another platform, it will produce an error. This was a problem with AWT. So I think that's why Java they found that these disadvantages are should be very fastly solved. So they created after 2 years only the Swing platform and put it into use. Compared to AWT, Swing is more lightweight, which means that the components in Swing they take less amount of memory. They can be processed in a faster way, so they are more light. That's what we mean by lightweight components. They take less memory. They can be processed faster than the components of AWT. Also, Swing contains much more features than AWT. For example, here we have the JTable. This is a very important graphical component which allows the programmer or user to display specific types of tables in a certain manner within the application. This was missing in AWT, but it existed in Swing. It was added to Swing. Another thing is that Swing is platform independent, while AWT was platform dependent, which means that AWT depended on the existence of certain libraries within each platform. On the other hand, Swing didn't need any libraries within any platform. It can be used within the JavaFX, within the Java environment at any platform without depending on certain libraries within the platform. In addition to that, Swing is pluggable look and feel, while AWT is native look and feel, which means that the general look of the application in AWT will differ from platform to another. So inside a certain platform, it will take the look and the feel of that platform. While on the other hand, the Swing, it has a standard look and feel. It will look approximately the same. The application will produce the same look and the same feel of the application on any platform that you run the application on. Finally, we can say that Swing was designed to be much faster than AWT, mainly because its components were more light and its behavior was better than that of AWT. So Swing remained in use for about 10 years. After that, JavaFX was released. The main reason for producing JavaFX was basically for two main reasons. The first one is to add new main components to the graphical user interface platform of Java. For example, you have here, let's say, the collapsible tiled pane, the accordion control. These are examples of them. The tiled pane is the collapsible tiled pane is a pane in which you can collapse the content of the pane or show it. So here it is shown. If I click here on this drop down symbol, then the whole content of the pane will be collapsed within a small area of the pane. You can create collapsible tiled panes within something called the accordion. So here we have an accordion which contains inside it 3 collapsible tile pins. There are many other components that were added to JavaFX as compared to Swing. So as you know, in nowadays mobile applications and web applications, you have maybe hundreds of components, different components, in which each component might differ slightly from other components within a certain same category. In order to add the existence of all such components and to enable users to produce applications with rich content in them, Java added or created the JavaFX platform and added it in 2008. This was the first basic reason for the development of JavaFX. The second basic reason is to add the possibility for the user to develop mobile applications. So Swing did not contain any type of support for mobile applications, while JavaFX it contained support for mobile applications. And there is a nice article here on the web that shows you how you can create a Java application for mobile devices. So you can go to this link, community.oracle.com/docs/doc918697. You can find this article which will explain to you how you can use the JavaFX platform to develop a graphical user interface for a mobile application on the mobile operating system. A third main thing that was added to JavaFX, which didn't exist in Swing, is the cascading style sheet, or the CSS. You probably should know about CSS by now. You should have taken it previously in one of the programming courses or in the web development course. In case you don't know about it, we will have a certain part of this chapter, the JavaFX chapter, in which we will talk in details about the CSS. For now, you need to know that it is a certain scripting language that allows you to add styles and different looks, different appearance to components, various graphical components in JavaFX. Also, JavaFX has special effects such as shadows, reflections, blurs, and animation. Most of these did not exist in Swing. We are going to talk about some of them. We are going to have at the end of the chapter a part of the chapter at the end will be focused on animations, creating animations. We'll see how to create a timeline, for example, and how to edit the components of the animation. So this was a brief introduction about JavaFX and its components, its distinctions, how it is distinct from previous graphical user interface platforms that were developed by Java. Now we'll start with the structure of JavaFX and its main components. What does it contain? How it allows the user to create graphical user interface applications. So any program, any class in Java that you want to use as a graphical interface class, if you want to transform a certain class from an ordinary class that runs on the console to a graphical class that shows a graphical interface for the user, then this class should inherit, it should extend the application class. The application class is the main class in JavaFX. So you have the main JavaFX package, which contains all classes within the platform. The main class in this package is the application class. So any class that you want to create as a GUI application, this class should extend, it should inherit from the application class. So for example here, I'm going to show you very simple class called my JavaFX. This is the first class we are going to talk about at the end of this lecture. But just a brief thing that this class extends application, which means that when I add this part extends application, This means that this class will now appear as an application. What do we mean by that? It will appear as a window, as a uh, graphical application, not a console application. So if I remove this, if I make this class an ordinary class, doesn't extend application, when I run this class will be run in the console. It will not appear as a graphical application. If I add extends application, this class will appear as a graphical application to the user. Now, application here is the main class in JavaFX. So you can see here we have inside JavaFX package, we have a package called application. Inside this package, I have the main class of this package is the class called application. Now, within application, I can create within any application a set of graphical components. The father or the main class of all graphical components is the stage class. If you want to create any application, you must put a stage inside this application. The stage is a graphical component that contains a set of scenes. You can think about the stage as a window. So any window, it is a stage. So here, for example, I have a PowerPoint window. In JavaFX, this is called a stage. If I open another window, such as the Eclipse, so here I have the Eclipse window. In JavaFX, this is called a stage. Okay, so any window in JavaFX, it is called a stage. Now, inside a stage, you can put one or more scenes. You can create one or more scenes and put them inside a stage. Now, what is a scene? A scene is a container of graphical components. You can put a set of graphical components inside a certain scene. And then you can put a scene inside a stage. Now, why is this so complex? You might think that JavaFX had made a complex structure of their graphical user interface application. Why just not put everything all graphical? Why not put all graphical elements directly inside the application, for example? Why do I need to create a stage and then to create a scene inside a stage? Basically, because JavaFX allows you to create several windows within one application. So one application here doesn't have to have only one window. It might have several windows. Each one of these windows will be a separate stage. Okay. Now, inside each window, you might have several scenes, several containers. So, for example, here in PowerPoint, I have here the main scene, which contains all these components. Now, in JavaFX, you can create multiple scenes, not only one scene. You can create here a scene that contains all these components, the menu here, which contains the tabs, and then inside each tab, I have different elements. So inside each tab I have different, as you see, different elements. In JavaFX, you can create multiple scenes inside a single window, a single stage. So you can switch between scenes as you want. So you can think about this as if you have a certain application. Inside the application, you have a certain window. Then in the window, you might want to set up several forms, different forms. So you need to switch between one form and another. So you create each form for each graphical interface as a separate scene, and then you can switch between scenes according to the code, according to the behavior, to the activities and actions that are done by the user. Each scene will create inside it a set of graphical elements. We will refer to each graphical element as a node. So the class node will be the father or the main class from which all graphical elements will inherit. So any graphical element such as the text, the field, the label, the button, the image, any graphical element, it will be a separate class that will inherit from the node class. A special type of node is called the parent node. So nodes in general will be either parent nodes or non-parent nodes in JavaFX. Parent node is a special type of node. So you have here, for example, a parent, and then you have a node. Now, any graphical element will be a node, but not all graphical elements will be parents. The difference between a parent node and a non-parent node is that a parent node, it can contain inside it other nodes. So I can put nodes inside a parent node. While if a node, a certain node is not a parent node, a non-parent node, then this node cannot contain inside it other nodes. It will contain inside it specific graphical content that is strict to this node only. So you can see in general, we have inside the application, we have stages. Inside each stage, we can have one or more scene. And then inside each scene, we will have a set of nodes. Some of these nodes will be parent nodes, which means that they can contain inside them other nodes. And some of these nodes might be non-parent node, which means that each one of these nodes will not be able to contain inside it other nodes. It will contain specific graphic content. So if we look at the tree structure of the graphical elements in JavaFX, you can see that the main class is the stage class. The stage class will be used directly inside the application class. Each application will contain one or more stages. Inside the stage class, we have, or down in the lower level of the stage class, we have the scene class. Each scene will be a graphical class that will contain inside it graphical elements that are nodes. Now, as you can see, each stage can contain one or more scenes. So each scene will be put inside a stage. Okay, that's this composition here, composition symbol of the UML model. Each scene will be put inside one stage at a certain time only. Each stage can contain many scenes inside it. Inside each scene, we can have multiple nodes. Now, in order to put a node inside a scene, this node should be a parent node. That's why a scene will contain multiple, one or more parent nodes. And each parent node will be put inside a certain scene at a certain time. So the general class that is the father of all graphical elements is the node class. From this node class, we have two types of classes. We have either a parent node, which is a class that inherits from node. So a parent is a special type of node, which is a node that can contain other nodes inside it. On the other hand, we might have some nodes that are not non-parent nodes, such as the media view, the image view, and the shape. These are specific types of nodes, JavaFX nodes, but these are non-parent nodes, which means that inside a shape, I cannot put other node. Inside an image view, I can put only images. I can't put other nodes. I can't put text or label or button or any other node. So these are non-parent nodes. They cannot contain other nodes inside them. They just contain a specific graphical element, such as images here, media files here, specific drawings here. Okay. On the other hand, the parent nodes, they can contain other nodes inside them. Now we have two main types of parent nodes. We have either panes or controls. The difference between these two is that the panes, they don't contain objects. They don't contain graphical objects. They contain other nodes. So the only main purpose of a pane is to play the role of a container. A pane is just a container. It contains other nodes only. It doesn't display its own specific graphical content. On the other hand, a control, it's not a container. It is a object that has its specific So I was saying that a control is a graphical object that doesn't contain, it's not a container. It has its own graphic content that it shows it in the program. Example of controls are labels, buttons, radio buttons, text fields, text areas, and so on. So inside each one of these controls, I can put other nodes. Okay, but they are not just only containers for nodes. They have their own graphical content that they show. For example, a text field, it shows text. You can put text into it. So this text is a specific specification of the text field. Okay, a button, it shows also text. You can click on this text. So this text is specification for the button. On the other hand, a pane, it doesn't contain its specific own graphical content. It doesn't contain its own specific text or specific image or any type of graphical content. It is just a container. You can put inside this container other nodes. So you can group several nodes together and put them inside a pane. So as I said, in general, a scene will contain several parent nodes inside them. So each scene can contain one or more parent nodes inside them. Well, each parent node will contain other nodes. These other nodes might be parent nodes or might be ordinary nodes. Now each parent node also will contain other nodes and so on. This will lead to something that we will call a scene tree structure. We will talk about this shortly. First, let's talk about the general concept of a stage. So the stage is the location where all the graphical elements will be displayed. It corresponds to a window in a desktop environment. I already said that and explained this in details. The stage is defined. The stage is defined in JavaFX using the class stage inside the package stage in the main JavaFX package. So you go from JavaFX. Inside this, you have a package called stage. Inside this package, you have the class stage, which is used to instantiate and create objects of type stage in applications. We have something called the primary stage. When you create a new application, each application will have at least one stage. Now this stage, the default stage in the application, is not created by the user. It's automatically created by the Java runtime environment. So the JavaFX framework will automatically create a default stage for each new application that you will run. This automatic stage is called the primary stage. The user don't need and will not create this primary stage explicitly. It is created implicitly by the JavaFX framework. The user just uses it inside the program. How this is done? If you take a look at this sample, very simple JavaFX example, you can see that I have a class here that extends application. Now there is a method called the start, which will create the application. So there is a method called the start inside the application, which will create the application in a new thread. Now I don't know if you know about multi-threading in Java or you don't. In general, multi-threading happens when we want to create application that will run several classes at the same time. If we want to run several classes concurrently in parallel, we use multi-threading. Now inside Java, everything is a thread, which means that you can run several classes together, and each one of them will be running as a separate execution point, separate thread. So when I run this class, my JavaFX, it will be created and executed inside the Java runtime environment as a separate thread. I can at the same time run this class and run other classes together in parallel. Why is that? Because I am running each class as a separate thread. If the JavaFX didn't support multi-threading, this will mean that I can run only one class at a certain time. I cannot run multiple classes together. Now in multi-threading, there is a method called the start. This start it can be found inside the class thread. This method start, it will execute the class as a separate thread, which means that you will create for the class a separate execution point, and then you will run this class within this execution point in parallel with other classes. So calling the start method will enable the user to run the class, execute the class in a separate thread. That's why we use the start method here inside the JavaFX in order to run this application as a standalone thread in parallel with other applications and programs. You all know that inside each class, Java class, we have to have a method main. We need to have a method main. This main will be the starting point of execution of the class. So when we execute any class, the runtime environment, the Java runtime environment, will start execution the main method. So we will start executing the class from here. Inside this main method, I'm calling the launch method. The launch method is a method inside the application. It will call the start method and pass to it the primary stage. So the launch method is responsible. It is responsible for creating the primary stage, the main stage of the application, and then it is responsible for calling the start method of the application to execute the application as a separate thread, and passing to this start method the primary stage which was created by the launch method. Okay, so this can be this should be a standard for any JavaFX application that you create. Whenever you want to create a JavaFX application, you put the you call the launch method from inside the main method. Okay, so when you call this method, you are automatically telling the JavaFX runtime environment to create a primary stage, and then to call the start method of the thread of that will run this application, passing to the start method the primary stage that was created in the launch method. Okay, so as I told you, this primary stage will be automatically created and passed by the system. You don't have to create it manually by yourself. It's automatically created here. So that was with respect to the stage. Let's talk now about the scene. As I told you before, the scene is the container which will contain inside it a group or a set of graphic components that will display inside the scene. So you can create multiple scenes. In each scene you can create different graphical components. Then you can switch between scenes inside the stage. You can set the scene of the stage to a different scene. Inside each scene, we have a set of graphical components. They are called the nodes. These nodes are usually organized inside the scene into something called the scene graph, which is a tree that has a root, and the root will have children, the children will have children, and so on. What does this mean? If you look at any JavaFX application, so let's see here, for example, any JavaFX application. Let's take a look at this one. So you will see that inside any scene, you might have several components inside each other. So this one here, it doesn't show you this very much. Let me search here about nested panes, for example. So if we take a look at any one of these, this one for example, this is a JavaFX stage. This is a complete stage. You can see inside this stage I have a scene. This is a single scene. Then inside the scene I have several graphical components, several graphical elements with each other, grouped with each other. Now how do I group these elements? First, I should have a root element that will contain all these elements together inside the root element. So this is usually a pane, a certain type of pane. As I told you before, a pane is a container. It contains inside it other elements. It doesn't have a specific graphical, any type of graphical thing to show. It's just a container. So here I might have here, for example, a general pane. I might have vertical box, a certain type of pane. Inside this pane, I might have other panes. So this is a single pane that contains inside it all these components. Each one of these components might be a standalone pane. So I might have here one, I might have 1, 2, 3, 4, 5 panes, for example. This pane will contain inside it other, this pane will contain inside it, for example, here, one pane here, 1, 2, 3, 4 panes here. Now this pane can contain inside it, this one can contain inside it a single text field. This pane can contain inside it labels and objects, shapes, and so on. You might have certain panes that contain inside them only buttons. So in general, you group your components into panes, then you group these panes into other panes, then you put all the panes together in a root pane, and then you put this root pane in the scene. So a scene might contain a single root element. It might contain a single root element. It might contain a root element. Inside this root element, I have other parent elements. For example, this root element here contains a parent element and a non-parent element, a specific node. This parent element could be a pane. It contains inside it two non-parent elements, two nodes. This is how graphical objects are grouped inside this scene, creating this scene graph. In general, all objects that are the leaves of the scene graph, the scene tree, all objects at the leaves, they are non-parent nodes. While on the other hand, all objects that are not leaf elements, they are parent nodes. So the root node should be a parent node in general, because it will contain other nodes inside it, and all other nodes that contain other graphical elements, they are also non-parent nodes, such as panes. So a general rule of thumb is that all objects that are children of the scene graph, these are non-parent nodes, and all objects that are not children, these are parent nodes. Now, when you create a scene, you add it to the graph using the method setScene. So you say scene equal new scene. You put inside it the root element. Then you say primary stage dot setScene, and you give the scene as input to the constructor, as input to the method, which is setScene. I already talked about nodes and parents. I said that parent is a class that inherits from node, specific type of nodes. Parent is a node that contains other nodes inside it, as I said before. Now, the main class that contains all these classes is the class node inside the package scene. Each scene must contain at least one node, which is the root node. This could be a parent node that contains other nodes inside it, or it can be a simple node, any node that can be put here without having it to contain other nodes inside it. So any type of nodes that contain other nodes, that it should be of type parent. It should inherit from class parent. So let's explain this first example to you so that you understand it very well and understand how all these components are mixed together and can be put together in a single application program. As I said, this is a class that extends from application so that it can appear as a graphical graphical program. I talked about why we need to call the launch method from the main method, and how it creates a primary stage and inputs it to the start method of the thread that will run the application. Inside this start method, I create all the graphical components that I need to put in the application and display them. How do I do that? First, I use the primary stage, which is input to the method, to put components inside it. I need first to create the graphical components. So in this example, I'm creating only a single graphical component, which is a button. The class button in JavaFX, it is found in the package scene. Then we have a package called control inside scene, and inside this package control, I have a class called button. So whenever I want to create a JavaFX button, I need to import this class. So here I'm importing this class within the scene package. Then I want to create an instance of class button. So I say button, then I give a name for the instance of this class. Then I call the constructor of button. Now in the next lecture, we will talk about the button element, what different constructors are supported by the button class. We can pass here a text that will be displayed on the button. We can pass a text and other node to the button. We will see, we will talk about that in the next lecture. For now, I'm creating a simple button that has inside it the text OK. So when I run this application, this Java class, I will see a button which has the text OK inside it. I can click on this button. Now, how do I add this button to the scene? I create the scene as for example, or scene. This is an instance of class scene, which is also found inside JavaFX.scene package. So I call the constructor of scene by passing to it the root element, the root of the scene graph. This root I pass it to as input to the scene constructor, and then I put the size of the scene. I add here the size of the scene as the second and the third input elements to the constructor of the scene. Now inside scene, I have several constructors. I can use this constructor, I can use other constructors. I can say, for example, instead of saying scene equal new scene, instead of putting the bt OK and then the size of the scene, I can just input into the scene the root element only, and this will be OK. So here I'm not inputting the height and the width of the scene. I'm leaving that for JavaFX to create it automatically according to the calculated size, which means that I can use one of several constructors for the scene class. This one will take only the root node in the scene graph. This one. Okay. The second constructor. So the second constructor which I can use, this one, it will take the root node. It will take also the required dimensions of the scene. So when I run the program, if I save and run, you will see that the button will be displayed inside the scene with these dimensions, which are 200 width and 250 height. 200 pixels width and 250 pixels height. Now if I change the size, if I put it, for example, 100 by 100, you will see that the size of the complete application will be changed according to the new width and height that I put, which are 100 by 100. Okay, 100 by 100. So you can specify any size that you want. Now, in order to let the JavaFX calculate the size automatically according to the needed size for the buttons, for the objects that are put inside the scene, you omit the values of, you don't pass the values of the width and the height, and you just pass the value to the constructor, just pass the value of the root node. In this case, JavaFX will calculate the required size of the application automatically by adding all the sizes of the graphical elements on the application, and will display the application with this calculated size. So here I have the default size of a button. This is the default size of a button displayed inside the stage, displayed inside the scene, and then the scene is displayed inside the stage. Okay, so the required size is here only the size of the button. I can change this size as I want. After I create a scene and specify the root node of the scene. Now I add this scene to the primary stage. I say primary stage dot add scene or set scene, and I input to the method set scene the scene that I want to display inside the primary stage. Okay, so you can create multiple scenes. You can put any scene that you want inside the stage by calling the method set scene, and you can alternate between these scenes at any time you want according to any code that any behavior that you put. We will learn in the next lectures how we can create events. According to the events, we can change the scenes inside the stage of the application. Also, I can display a different title for the application by putting the title here by calling the method subtitle. So I say primary stage dot subtitle, and I put inside I pass a string value to the method subtitle. This string value will be displayed as the title of the application. So when I run, you can see the title will be my JavaFX. This is the title displayed here. Finally, in order to show this So in order to show the stage, to make the stage appear, I must call the function .show. If I don't call this function, the stage will be existing inside the program, but it will not appear on the desktop. It will remain hidden. In order to show it, I must call the method show. Okay, it displays the stage. Okay, so we will learn in the next lectures how to create different multiple graphical elements, multiple graphical components, how to nest them inside each other, and how to put them finally inside a single parent node, which will be the root node, and then how to put this root node inside the scene like we did here, and display the scene on the stage. Okay, this was a general brief overview about the main components in JavaFX, which are the stage, the scene, the root node, the graph structure inside the scene, and how to set the title and set the scene of the stage, and how to show the stage. Finally, before we finish this lecture, I'm going to give you an example how to create multiple stages inside a single application. So we'll see a class called multiple stage demo. Inside this class, I'm going to create an application which contains multiple stages inside it. So as usual, we have here the method main, which contains the launch method, which will create the primary stage and call the start method of the application to start the application as a separate thread, as I said before. We will be using this structure, which is the main method, the launch, the existence of the launch method inside the main, and the start method within the application. We will be using this structure in all the applications that we will create. Here, what we have different from the previous class is that we are creating two stages. We are creating first a scene called scene, and we are adding to this scene a new primary node, which is a button. So here we are passing the button directly inside the constructor of the scene without creating it outside the scene. So this is the same as we say when we say button b, for example, equal new button, and then we put inside this, okay, and then we can say scene as, for example, scene equal new scene, and then I say here b. So this one doing this is equivalent to doing this. Instead of creating the button separately and giving it a name, I can pass it directly to the constructor of the scene using this. Okay. And here I'm passing also the size of this scene, which is 200 pixel by 250. Thus, I'm putting the title of the primary stage as my JavaFX, and I'm putting this scene, the one that I created here, as the scene of the stage by calling the method setScene as I said before. Then I am showing this stage. Now I want to create a second stage in my application. So I say stage equal new stage. I'm creating a new stage with the name stage, an instance of class stage, capital S, called stage with small s. I'm creating a second scene, which is called I'm not creating here as a separate object. I'm just passing it directly to the constructor or to the setScene method of this stage. So I'm saying here stage.setTitle, second stage. I'm giving a different title for the second stage, and I am calling the setScene method of this stage. I'm passing to it a new scene. Now I can create this new scene separately outside as I did here by saying scene s, for example, equal new scene, and I'm putting a new button inside the this scene, or I can do it directly by passing, without giving a name for the scene, passing it directly to the setScene method of the stage class as I did here. So I'm passing the button directly to the constructor of the scene. Then I'm passing the scene directly without giving it a name to the setScene method. Okay, and then I'm showing this second stage. Now before that, I'm calling a method called setResizable. I'm passing to it a boolean value equal to false to this method. This method setResizable it allows the user to the developer of the program, the coder, it allows to him to lock the stage, to make the user not able to resize the stage. So when you pass false to this method, then the size of the stage will be fixed. You cannot change it. By default, this property of the stage is true. So by default, you can resize any stage, give it any, move it to any size that you want. But if you call this method of the stage and pass to it the boolean value false, this will cause the size of the stage to remain fixed. This will cause the user will be not able to resize this stage. So you can expect here, when I run this program, you can expect to have two stages, not a single one as we had in the previous program. We will have a stage called my JavaFX. We will have another stage called second stage. The first one will be resizable. You can resize it because by default its resizable property is true. The second one will be unresizable. You cannot resize the second stage. So if I run this program, you can see here we have two stages. The first one is my JavaFX. This one is resizable. You can resize it any size that you want. The second stage is not resizable. If you try to resize it, if you move the mouse to the place where you are able to resize this stage, the mouse will not change its appearance in order to allow you to resize this stage. This one will be not resizable. Okay. Once you click a button, you will see that the border of the button will change its appearance. So this has shown to you that we can create multiple stages inside an application in Java, and we can put anything that we want inside any one of these stages. So this is in general everything that is required from you for this first lecture. In this lecture, we talked about JavaFX in general. We showed or described the distinction and the difference between JavaFX and previous graphical user interface platforms that were created by Java. We identified and described the main components of a JavaFX application. We talked about stages and scenes and their characteristics. We talked about the nodes and the difference between a parent node and a non-parent node. And we took two simple examples that show you how JavaFX applications are created. Next time we will start talking about the components, the different types of components and graphical elements that we can put inside a JavaFX application. Thank you.